Today we are continuing with our volumes of solids of revolution. We're going to be determining volumes of these solids using a different method. Today we're going to be using the cylindrical shell method. Okay. First of all, let me say that this topic is optional for me to teach. It's not covered on the AP exam. It's not on College Board's curriculum, but it is taught in Calculus 2 courses in college. That's why I teach it to you. Your Calc 3 professor, if you go straight into Calc 3, they will think that you have learned, that you have seen this method before. That's why I teach it to you. And it will be convenient to use on my test. All right? Now, we are still finding volumes of solids of revolution. And that means that we can use either the disc and washer method that we used yesterday or the cylindrical shell method. Okay, you can use either one of those because they do the same thing. So if you know the disc and washer method really, really well, then you have no use for the cylindrical shell method. Okay? Alrighty. But by the end of today, hopefully you'll know when you might want to use the cylindrical shell method and when the disc and washer method is preferable. Okay? All right. With solids of revolution, rather than using cross-sections would be the disc and washer method. Rather than using cross-sections to describe the solid, we can use cylindrical shells. Let me show you what I mean. Let's revolve this region around the y-axis. So we're going around the y-axis. Let me grab a color here. Going around the y-axis, so just like always, I'm going to put a dashed line on our axis of revolution. And we know what the solid is going to look like when we revolve it around the y-axis. It's going to be reflected over here. Well, something like that, yeah, and it's going to go around like that, outside, inside, etc., right? We're definitely going to have a hole in the middle, right? So here's what we're going to do. I'm going to come in and just draw a little vertical line right in here, a little vertical line. I'm starting at x is equal to a. I'm going to end at x is equal to b. A little vertical line, okay? And I'm going to revolve that line around my axis of revolution. When I revolve that line around the axis of revolution, what is that going to make? Can you see the little cylinder? But it's not a solid cylinder, is it? Because all I did was revolve the line, the little line segment. So it's not a solid cylinder, it is a cylindrical shell. If I give that a little thickness, then when I revolve it, that revolution has a little thickness, right? A little thickness. And anything with thickness, I can find the volume of. So what is the volume of that cylindrical shell? Well, that cylindrical shell by itself, that one shell, has a volume of the volume of the outside, so area, well, not area, it's the circumference of that circle, which is 2 pi r times the height. 2 pi r times the height. The area of a cylindrical shell is 2 pi r times the height of the cylinder, okay? So that would be just the area of that cylindrical shell. Once we give it thickness, then we're going to be multiplying it by a little thickness, which in this case is a dx, because the little thickness is in the x direction, right? So the volume is 2 pi r h times our little thickness. Oops, I should have called that delta x, not dx. The dx will come, right? Okay, now I'm going to go to the next cylindrical shell over, the next one over. Things are going to start to look messy here, but I'm going to go to the next one over and rotate that one. Give it a little thickness. We can find its volume. I'm going to add it to this volume, okay? Keep on going, and I'm going to be getting all of these cylindrical shells from the very, very teeny tiny first one in here all the way to the last one, right? Add all of those up from the first cylindrical shell to the nth cylindrical shell, and then we are, like always, going to let the number of things, in this case cylindrical shells, go to infinity. And we get the integral 2 pi r h dx from a to b. And these are x's, right? Therein is the beauty of cylindrical shell method. With cylindrical shell method, even though we have a vertical axis of revolution, we get to keep our dx's. So you will see me often, not always, often I will use cylindrical shell method whenever I have a vertical axis of revolution. Okay? So, integral 2 pi r h delta x from a to b. And yes, you could have it as a dy, but in my mind, what's the point? I'd rather do a disk and washer. Okay? Alrighty. Our h is the height of the cylinder. So the height is top minus bottom. The height is your top curve minus your bottom curve. Every time. Every time. Okay? The only thing about this method that is vaguely tricky is the r, the radius. Okay? And we will go about how to find r. But r is the radius of the cylinder. R is the radius of the cylinder. Cylinder. Gosh. Cylinder. Okay? Alright, and we'll go about how to find that in a moment. Okay, it's easiest to tell you how to get r in some examples. Okay, let's consider the region R bounded by the graphs of x squared, y equals 0, that's the x-axis, and x equals 4. Well, apparently we're going to change that to x equals 2 because I have a 2 down here, and we will match that. I don't know why I had a 4 there, but there you go. Change that to a 2. Okay. We're going to revolve R about the y-axis. So I'm going to put a dashed line on the axis of revolution like I always do. And this is one where I could very easily do the disk and washer method. But I'm going to do the cylindrical shell method so that we get some practice. Okay, here's how I do it. I'm going to draw one vertical slice, top minus bottom, in the region. And I'm going to rotate that one, just that one. You don't have to draw all of it, but it might help you to draw one. Okay? Our formula for cylindrical shell method, 2 pi r h dx. That's our formula. H is top minus bottom, so I already know what's going to go there. The trickiest part is the r, so let's talk about the r. R is the radius of this cylinder, so that is R. The key to finding R, I'm going to put it in a box right here. The key to knowing what R is to knowing what X is. X is always the distance from the y-axis, the y-axis to your slice. And when I say slice, I mean your top minus bottom slice in the region. Okay? X is the distance from the y-axis to your slice. So from the y-axis, which happens to be our axis of revolution in this one, from the y-axis to the slice is X. So in this case, the radius of the cylinder is R, but it's also X. So in place of R, I will put X. So we will have 2 pi times X times top minus bottom. Top is X squared. Oops, yeah. Bottom is 0. And our boundaries. Use the boundaries of your region. Not your completed project, just of your region. So we're going to go from 0 to 2. 0 to 2. Math 9, 0 to 2, 2 pi times x squared. Of course, I could have made that x cubed, dx, and that is 25.132, or 133 at the end. Okay, let's do another one. Let's take that same region, but this time we're going to revolve it around x equals 6. So around x equals 6, okay, I'm going to draw one slice in my region, always in your region, and revolve that slice around just to get an idea of what your one cylinder looks like. 2, 3, 4. Something like that. And of course it does not have to be exact. It's just to get an idea of what that cylinder is. The key is I want you to be able to see what your radius is. Okay? So the radius of the cylinder is this distance right here. It's that distance, yes? That's the radius. Okay? So we're using cylindrical shell. So still 2 pi RH. 2 pi RH. Remember that, 2 pi RH. Okay? H is the easy one. H is top minus bottom of your region. So H is going to be the x squared minus the 0. R is the only thing that makes this even vaguely tricky, and it's really not that tricky if you remember that x is the distance from the y-axis to your slice. So x is the distance from the y-axis to your slice. So from that, and knowing that this is 6 out here, how big is R? If this is x and this is 6, then what is R? R is 6 minus x, right? That's the only thing tricky about this. And I don't think it's that tricky. 2 pi 6 minus x times top minus bottom x squared minus 0 dx. And we're still going from 0 to 2. You always use the boundaries of your region, not your finished project. Okay? So we have Math 9, 0 to 2, 2 pi times 6 minus x times x squared. 75.398. So notice in each of these we have these vertical axes of revolution, and that's when I use the cylindrical shell method. Even at that, sometimes I still go back and use the disk and washer method. Okay, let's find the volume of the solid formed by revolving the same region around x equals -3. So this time we're over here at x equals -3. Okay, just like we have been doing, I'm going to draw a single slice. Anywhere in my region, I can see the top minus bottom. That's my slice. And now I'm going to revolve this around the axis of revolution so that I can see a cylinder. Okay? Just so you can see a cylinder. I need you to be able to see your radius. So the radius goes from the axis of revolution, which is always going to be the middle of your cylinder, to your slice. Yeah? That's your R. That's the radius. So where is the x? X is from the y-axis to your slice. So this is x right here. And this is -3 here. So how can I write what R is? R is this distance. R is a distance. So what is R? Well, R is this distance plus x, right? So R in this case is x plus 3. So 2 pi RH, 2 pi R is x plus 3 or 3 plus x, whichever. H is top minus bottom of your slice. So top is x squared, bottom is 0. And we are still using 0 to 2, the boundaries, the x extremes of your region. Zero to 2, 2 pi, 3 plus x times x squared. Happens to be the exact same thing we had above. All right, let's look at a different region. Let's let S be the region bounded by the graphs of sine and cosine from pi over 4 to 5 pi over 4. Let's first find the volume of the solid formed when region S is revolved around the y-axis. So here's the y-axis. I'm going to make a single slice and revolve it around that y-axis. Just so I can see the cylinder. I need to be able to see the radius. So here's the radius of the cylinder. And since our axis of revolution is the y-axis, x will be r. So, integral 2 pi RH dx, integral 2 pi, the radius of the cylinder is just x, the height of the cylinder, top minus bottom. Which curve is on top? Which curve is on the bottom? Sine is the curve that goes through the origin, so sine is on top, cosine is on the bottom. And what are our boundaries? They are our x extremes, pi over 4 to 5 pi over 4. Math 9, pi over 4 to 5 pi over 4, 2 pi times x times sine x minus cosine x. Another reason I like this method is because I don't have to square anything, and that is something that I find that students tend to forget when they're putting things into their calculator. Okay, part B. Find the volume when that same region is now going to be revolved around the line x equals negative 2. X equals negative 2. Well, where is negative 2? Negative 2? Somewhere over here, yeah? Pi is 3.14159, yeah, 3.14. Half of that is 1.5 something, so it's somewhere. I really don't care where it is, but it's somewhere over here, yeah? Take your slice. I guess I can be consistent with my colors. Take our slice. Revolve that around our axis of revolution just so that we can see our radius. I just need to see our radius. This is negative 2 over here. So that's the radius of our cylinder. What is x? X is from the y-axis to the slice, right? So how can we write r? Well, this distance is 2, and r is 2 plus x. So integral 2 pi rh dx, r is going to be 2 plus x. H is top minus bottom, sine x minus cosine x. And our boundaries are still the same. Math 9, pi over 4 to 5 pi over 4, 2 pi times 2 plus x times sine x minus cosine x. $77.416. Okay, one more. We're going to take that same region. This time we're going to revolve it around x equals 7 pi over 4. Notice that in every example these have been vertical axes of revolution. That's the only time when I would prefer to use this method. Otherwise, I'm going to be using the disc and washer method. So 7 pi over 4 is out here. I'm going to draw my slice anywhere in your region, just so you can see the top minus the bottom. Revolve that around so that we can see the radius. There's the radius of our cylinder. Say what x is. X is from the axis of x is from the y-axis to your slice. So what is r? This is 7 pi over 4. That's r. That's x. From here to here is 7 pi over 4, right? So r is 7 pi over 4 minus x. So 2 pi rh. R is 7 pi over 4 minus x times h, and h is top minus bottom, sine x minus cosine x dx, and we use the same boundaries, pi over 4 to 5 pi over 4. And let's see, this time I'm going to just scroll up. I don't want to have to repeat most of it because all I have to do is go change what r is, right? So I'm going to go in here and change that to a 7, and now I'm going to insert, second insert, pi over 4 there, so 7 pi over 4, and then a minus, and then I'm going to delete that plus, make sure that that's right. I think that's right, and we get 55.830. or 831. Alrighty. And that is the cylindrical shell method. So, two ways to get volumes of solids of revolution. Disk and washer, I use that for horizontal axes of revolution, and I use cylindrical shell for vertical. That's what I would use this for. Okay? But it is important that you know that it's not tested on the AP exam. So, on a question, on an FRQ, if you were asked to find the volume, if you were asked to find a volume, you can use either method you want. Even though it's not specifically taught, anybody grading your test would recognize the cylindrical shell method. We all know it. So you can certainly use it. Even though it's not required that you were taught it, you can still use it. Alright? However, if it's a multiple choice question and they say which integral gives the volume, it will not be a cylindrical shell method, just so you know. It will always be the disk and washer method. Alright? Now, on my test, not true. On my test, I've taught this to you, I expect you to know it. So I expect you to know both. Okay? So on my test, if I say which integral gives the volume, it might be a cylindrical shell, or it might be disk and washer. Okay, so know both. Alrighty, that's it.